Alright, this video is a review of our polynomials unit. Do not copy off of this video. Make sure you can do every single problem by yourself. Alright, for number one, we're supposed to list off the possible rational zeros. That word possible is sort of a code word to remind you to do what I'm about to show you right now. It works like this. We're going to get some possible numerators. The possible numerators are going to come from the constant term. So the possible numerators are going to come from the 6. The possible denominators are going to come from the leading coefficient. So the possible denominators are going to come from 2. Now when I say come from, I mean they will be factors of. So what are all the factors of 6? Can you list them in order for me? 1, 2, 3, and 6. Okay? So those are all the possible numerators of any rational zeros I'm going to have. So what are my possible denominators? 1 and 2. Okay. So when you make your possible zeros, your complete list, all we're going to do is we're going to put all of these numerators over each of these denominators. And I'm going to do them one by one. Okay? So, and all of these will be plus or minus. So if I take, let me use different colors for a second. Okay, if I take all of these and I put them over 1, then that would be like this. It would be like, it'd be 1 over 1, 2 over 1, 3 over 1. I should be putting plus or minus on all of these. Let me try again. 1 over 1, plus or minus 2 over 1, 3 over 1, and 6 over 1. Obviously, I don't need to write the 1 underneath, so you're always going to wind up with your numerators first. But then I'm going to start putting the same numerators over the other denominator. So now I'm looking at the 2. So I'm going to take all of these same numerators, and now I'm going to put them over 2. Okay, so that's going to give me, okay, so I'm going to do 1 over 2, 2 over 2, 3 over 2, and 6 over 2. So for starters, I have 1 over 2. Okay, so I write that down. I start to do 2 over 2. Okay, but what happens with 2 over 2? That's just 1. I've already got plus or minus 1, so I don't need that. 3 over 2 is new, so I go ahead and write that down. Plus or minus 3 over 2. What about 6 over 2? No, because that's 3 already. We already have that. So that's the complete list right there. Okay, 1, 2, 3, 4, 6 pairs. All right, just pretend I wrote all that on the line. Maybe I'll cut and paste it. OCD rules my life sometimes. Okay, so there you go. So that's problem number 1. Well, 1A. Now, write f of x in factored form. Show all work for full credit. Okay, we're allowed to use our TI-30 excess multiview. I think we decided not to make separate parts for the test. We can design enough problems that require you to think. So you can do whatever you're capable of doing with the calculator. Okay? So we should go ahead and type this function into our TI-30 right now. Okay? Help me out a little bit. Okay, so I'll go to the table, type this thing in. So I got 2x to the third power minus x squared. Okay, that's not good. You know what? I'm just going to do it over. All right. 2x to the third power minus x squared minus 13x minus 6. Okay? So let's take a look. I always start from negative 10. So far, I've never seen it go past that, so negative 10 seems to be a good place to start. So I'm just going to scroll down looking for zeros on the y side. Okay, so the first zero I come to is negative 2. So I'm going to go ahead and use that negative 2 right now. Okay, so negative 2 is my first zero. And when I say use it, I mean let's do the synthetic division. So I've got 2, negative 1, negative 13, negative 6 as the coefficients up there. 3, 2, 1, 0. Okay, nothing's missing. Okay, so now I'll go ahead and do this and see what I've got. All right, so I'll bring this down. So that'll be 2. 2 times negative 2 is negative 4. That makes negative 5. That makes positive 10, negative 3, positive 6, and 0, as we knew that it would. So far, what's the factor that I get from the negative 2? I get x plus 2 is my factor. Okay, and then the trinomial is 2x squared minus 5x minus 3. So far I've factored down to this. Now looking at that trinomial, I'm wondering, is that further factorable? Probably. So I'm going to go ahead and give that a try. Okay, so as I factor this pink trinomial, 2x squared can only factor as 2x and x. All right, 3 can only factor as 3 and 1, although I might have to switch it and put the 1 here and the 3 here. I'll see. What's the matter, Emily? Remember, inner plus outer has to equal middle. Right now, inner I have 3x. Outer I have 2x. Is there a way I can get negative 5 out of this? There is. In the long run, it's not going to work, but to get negative 5, I would have to have negative 3 and negative 2. Right. So if I did negative 3 and negative 2, the problem with this, like Lauren is saying, is that I won't get the negative 3 on the end. A negative times a negative is a positive, so that's why this doesn't work. So look at your paper. If you factored it this way, this is wrong. Does everybody see why this doesn't work? Even though I get the negative 5 out of it? So I have to switch it. Okay, so I'll try putting the 1 on the other side. Okay, so we'll go 1 and 3. Okay, so again, we'll do inner plus outer has to give me the middle. But this time, inner, I have 1x. Outer, I have 6x. How can I get a negative 5 out of this? If I have a positive 1 and a negative 6. So there's my positive 1, and this will give me a negative 6. But this time I get the negative 3 that I want as well. Positive times a negative is a negative. So this is the correct factorization. Okay, so I'll still have my x plus 2 over here. Okay, so part B says write f of x in factored form. Okay, we just did it. So part B is now done. Okay, so I'm going to throw a box around it. Or I guess I'm supposed to put it on the line. For part C, we need to find all the zeros of the function. How am I going to do that? Yeah, set each one of these factors equal to 0. So if I set x plus 2 equal to 0, subtracting 2 from both sides, I get x equals negative 2. So that's one of my zeros. If I set 2x plus 1 equal to 0, subtracting 1 from both sides, dividing by 2 now. I get x equals negative 1/2. And setting x minus 3 equal to 0, I get x equals 3. So these are my 3 zeros. Don't forget about the fundamental theorem of algebra. The degree should tell us how many zeros there are if we count repeated zeros separately. So we're expecting to have 3 zeros, and there they are, 1, 2, 3. So we know we got them all. All right, any questions so far? Okay? All right, moving on to number 2. All right, given the graph of g of x, find all zeros of the function. Show all work for full credit. Okay, we have to find all zeros. So first of all, think about how many zeros there should be. How many zeros are there? How many?
2.
No. There are 4. How do I know there are 4 zeros? Right, because of the degree. Fundamental theorem of algebra. I understand, if you said 2, I understand why you're saying 2. You're talking about the rational zeros. Okay, you're talking about the real zeros. But there are probably imaginary zeros as well, because there have got to be 4. Okay, unless these are doubles. But if these were double roots, wouldn't there be a bounce here instead of going straight through? So I don't see any bouncing going on at these zeros. So these aren't doubles, so they're singles. That means there have to be 2 additional zeros out there. They're imaginary. Okay, we have to find the imaginary ones as well. So sure, let's use the 2 that we can see to find the 2 that are imaginary. Okay? So what are the 2 that you can see, guys? Yeah, -3 is one of our zeros, and 4 is the other. Okay, so I'm going to use -3 for starters. But synthetic, that's what we're talking about. So I will take my -3 and I'll do synthetic division with it. Okay, so let's see, 1, I'm looking at my coefficients now. 1, -3, -7. That's all I can remember at one time. 1, -3, -7, 21, -36. Thank you for being my memory for me. Okay. Okay, so far, here I go. So I got 1, multiply, I get -3. Add, I get -6. Multiply, I get 18. Add, I get 11. Multiply, I get -33. Add, I get -12. Multiply, I get +36. Add, I get 0. Alright, so far I have this. Luckily I have another 0 to use because grouping doesn't look good for me right now. Okay, 11 is prime, so there's no grouping happening here if I tried. So instead, I'll pick up from here with my my next 0 of 4. And I can just go ahead and put the 4 right next to the bottom row, and now it becomes the top row of a new problem. Okay, so I'll just make a new line like this, and a new box, and I'll do it again. Okay, multiply, I get 4. Add, I get -2. Multiply, I get -8. Add, I get 3. Multiply, I get 12. Add, I get 0. Okay? Once you get down to 3, you're golden. Because either you can factor it or you can use the quadratic formula. Okay? Either way, we'll get it. Okay? So the trinomial I have right now is x squared minus 2x plus 3. That's my trinomial. Let's not forget the factors that come from the zeros that we already have. Okay, if we ever needed them. This represents a factor of x minus 4, and this one represents a factor of x plus 3. So far we factored down to this. But probably this purple thing is further factorable. Okay, x squared, x times x. 3 times 1. Inner plus outer must equal middle. Alright, inner I have 3x. Outer I have 1x. What signs do I need to make -2x? -3 and +1 will give me -2. Right, I see what you're saying. I see you saying we have a problem here. Yeah, so that would mean I'd have a -3 and a +1. But several of you are correctly seeing that, wait a minute, we're not getting the correct sign on the 3. So as close as this was, that's a fail. So please, you have to catch this. Like on the test, I mean, think about it. If these really were the correct answers, what would be the zeros that we would have gotten?
-1.
There should have been a 0 here at +3 and a 0 here at -1. But we have the graph right here. You see a 0 at +3 or -1? No, there isn't one. So you should know that you're wrong. Okay? So this is unfactorable. That's why we have to use the quadratic formula. Okay? Remember, we were guessing that our remaining zeros were going to be imaginary. So this was bound not to factor. Okay, we're not surprised. So let's use our quadratic formula. Okay, right. Opposite of B. I have no voice today. Okay, let's start with the discriminant. So we've got A is 1. A is 1, B is -2, and C is 3. So the quadratic formula, we start with B squared minus 4AC. So yeah, remember, this is our quadratic formula right here, okay? You have to memorize this. This will not be given to you. So the B squared minus 4AC part under the radical, that's what we always do first. It's called the discriminant. So that's what I'm doing. Okay, so B squared minus 4AC. In this case, that means -2 squared minus 4 times 1 times 3. I didn't really need to write the 1. Okay? Now, you should be able to do this by hand. Okay? Because this is going to be +4 minus 4 times 3. Right? You can do this by yourself. So that's 4 minus 12. So that's -8. Okay? Or you could have typed this in your calculator. All right? But either way, you get -8. All right, as soon as I see that the discriminant is negative, I know I'm going to have imaginary numbers. Okay? Because the discriminant lives underneath the radical. So now let's go ahead and do the rest of the quadratic formula. So opposite of B, plus or minus, square root, all over 2A. Let's make all that happen right now. So opposite of B. So B is -2. So that means X is going to equal +2, the opposite of B. So +2 plus or minus square root. And here's my discriminant that we just found. -8 goes under the radical now. All over 2A. Well, A is 1, so 2A is just 2. Okay? Now, when I have a negative number under the radical, what happens? It turns into an imaginary number. Okay? So basically, correct. You're going to take that negative away, and it becomes an I in front of the radical. Yeah, I'm going to simplify it, okay? I'm showing it in painful step detail so nobody gets lost. So that negative sign became I. And then we can go ahead and simplify the square root of 8 like normal, which you should be able to do yourself, am I right? The square root of 8, that's radical 4 times 2, that's 2 radical 2. If that confused you in any way, I see a TI-30 in your future. Okay, 2 radical 2, right? Either way, you can do it. Okay, so for that reason, this becomes X equals 2 plus or minus, and there's my 2 radical 2. Where does that I go?
Right after that 2.
Yeah, right here between the 2 and the radical 2. That's where the I belongs. Okay? This can reduce a little bit, though. Okay? I like to put a little heart around these 3 numbers to remind me that it has to be all 3 or nothing. I can't just cancel a pair of them. I need 3 or nothing at all. Okay? But since all 3 of these are divisible by 2, we must do that. Okay? So if I do that, then I'm going to get X equals, all of these are going to become 1s, right? So I'm going to have 1 plus or minus, okay, 1, 1, 1. Okay, and then I've got that I radical 2. But a lot of this that I just wrote down is unnecessary, so I'm going to erase it. Do you know what I'm talking about? All right, like this 1 in the bottom. Do I need a 1 in the bottom? No. Do I need this 1 in front of the I? No. Do I need the 1 in the very front? Yeah, I need that one. Don't erase that one. So there's really no fraction. So it's really just 1 plus or minus I radical 2 once you erase all the unnecessary ones. Mr. Burton, if I leave a 1 in front of something, are you going to take off points? Yeah, I'm going to take off a point. Yeah. So mean. I used to like you. I don't like you no more. That's all right, sweetie. I love you anyway. Any questions about that one? Okay, so our complete answer, though. Let's not forget the zeros that we found before. So these are the 2 zeros that were not visible, but let's not forget the 2 that were visible. Okay, include them on your list. What were they? -3 and 4. I'll accept it in any form. It was -3 and 4. Okay, so these are all 4 zeros. 1 plus I radical 2, 1 minus I radical 2, -3 and 4. That's the complete list. Okay? All right, any questions before I go on? All right, this video is long enough, so I'm going to end this video right here. We'll pick up the next video with number 3. Don't be copying off of me. Pardon my grammar. I'm a teacher. I should do better than that.